Selamat Petang. Thank you so much all for being here. I put this in front of every one of my presentations. It's a lot of fun, and I'll just stare at it. Can we get the house lights lowered, please? Pardon? So I look up at this cat, and I just kind of reach. I just do this. Generally not this long, but again, I'm just stalling for the lights. And it calms me down. As long as you keep laughing, I'm going to keep doing it. Okay, that seems good. I'm so much more relaxed now. Okay, so let's talk about Node versions. So my name's Myles. I work for a small disruptive startup called IBM, and I contribute to a small platform called Node.js. It's worth mentioning, you'll see kind of at the bottom here, the opinions in this talk are my own. You got to just say that. If you're ever up on stage, I advise that you say that. Always cover yourself. But so versions, how do they work? So it turns out, versions are a lot like magnets, and stick with me on this for a second. Versions are a lot like magnets, primarily in the way that many people are pretty darn confused about how they work. Like, how do magnets work? I don't know. How do versions work? Well, I do know, so that's why I'm here. I'm going to tell you about it. But real talk, this stuff is complicated. There's a lot of moving parts, and trying to hold it all in your head at one time can be really hard, especially if it's not something that you're used to. But the nice thing here is that you don't actually need to understand everything to contribute in a meaningful way. I think this is a really great takeaway for software in general, or even just like life. But you don't need to understand everything to make a difference, to contribute, and to help make a difference. So what we're going to do is we're going to start with a small piece. We're going to break it down and figure out how this becomes something bigger. And the first small piece to talk about is semantic versioning. Raquel was awesome and brought it up earlier, and we see this. And any of you who have written code, how many of you have heard of semantic versioning before? Can I just see hands? That's awesome. That's a lot of you. For those of you who haven't, anytime you see a version number, that version number can be semantic versioning. I'll say can be, because some people just like to put random numbers in front of their code and it doesn't mean anything. But what semantic versioning is it's a contract. It's a contract from the people who are developing the code to the people who are using the code to let them know how the code works and what kind of changes to expect in between versions. We have the major, the minor, and the patch version numbers. And so let's talk a little bit about what those are. A semver patch. A patch is any change which does not add new features and does not break any expected behavior. A patch change can be an update to documentation. It can be an update to a test. It can be an optimization to make something faster. It could be a bug fix. There's a whole list of things that can come in a semver patch. And basically, as I was saying, the only thing that's important is it's not a new feature and it doesn't change behavior. What's a minor? So a minor is anything that adds any new functionality to a piece of code. This can be a new function. This can be an extended API. This could be a new feature that isn't even something that you directly call on, but it just kind of changes the way things work. Anytime that you add something new to a code and you're doing a release, you should do that release as a semver minor. And a semver major is any change that's breaking. That could be changing the name of a function. That could be changing the functionality of a return. In the Node project, we even consider changing error messages as semver major because of how many people rely on our error messages for making decisions or for checking things. You may be doing like a catch and then making a change based on the catch of a throw. So we'll get more into examples of things that are breaking a little bit later. So Node has a number of different release lines. We have the current release line, which is most recently released v7.2.0. That was released on Tuesday, or as I've learned, on Wednesday in Singapore. We have active LTS. There's versions 6.9.1 and version 4.6.2. These are two different release lines. V4 has been being released a little bit longer, and V6 is a little newer. V6 was actually moved into LTS about a month ago, and we'll talk a little bit more about what LTS is. It stands for long-term support. And we have maintenance LTS, and you're going to see v0.12.17. You'll notice that v0.10 is not on there anymore, which is really great. 10 was around for a long time, and it's great that we don't need to maintain it anymore because it was very different than all the other releases, and we'll talk about why. So as I said, v0.10 is no longer maintained, and v0.12 is actually going to be end of life in December. So if any of you are running Node in production at your companies, and you currently have stuff running on v0.10 or v0.12, you should work on getting that upgraded as soon as possible. And we'll talk a little bit later about what versions to use and why. So, we were talking about v0.10 and then v0.12, and then all of a sudden we jump to v4 and v6. So where the heck did v1 through 3 go? And what's the deal with 12? And where's 5? There's all these different numbers. What do they mean? So when the Node project was started, you had even and odd releases. And the even releases were stable releases, and the odd releases were unstable releases. And for a very long time, you would have, like v0.8, and that was a stable release, and it was expected not to have any breaking changes on it. And then you would have v0.11, where more experimental things would happen, or v9, where more experimental things would happen. And then when they were ready for a bump, they would bump up to an even number again. You're going to notice there's an interesting pattern in Semver. If you do not have a 1 in the first digit, your Semver minor digit actually becomes your Semver major digit, and your Semver patch digit becomes your Semver minor digit. And you end up losing the granularity of even having the idea of a Semver patch. This is a problem if you want to follow Semver direct, to the key and the spec. And that's why actually a lot of people suggest that you start your code at version 1.0, which may not be entirely intuitive based on practices in the past. Many people would wait until their code base was stable and reliable before going to 1, and using going to 1 as a way to signal that. Personally, I think having that extra granularity and the ability to stick to Semver is way more important. People will know the stability based on your documentation. So it started taking a really long time to get to v0.12. v0.10 was the stable version of Node for almost 2 years. And the path to 0.12 wasn't entirely clear, and even more so than that, the path to v1 was completely, people had no idea when Node was going to go to v1 and start being able to properly follow Semver. And a number of people on the project, fed up with waiting, forked the project in December of 2014. It's hard to believe that it's almost been 2 years since IOJS. When they forked the project, they did what is actually, interestingly, the correct Semver thing, and they released it as 1.0. So this new IOJS project came out. It came out with version 1.0. They still released binaries that were called Node. And you could have the choice to go and download Node v0.10, or you could go and download IOJS 1. And so as that project moved forward, it just did more releases. In February of 2015, right before Node Summit, Joint released v0.12. v0.12 did not have any of the updates that were happening in the IOJS project. It had a slightly updated version of v8, which was still quite old, unfortunately. And it had some updates to internationalization, which was very useful. But it had still continued to go further away from the direction that a lot of the community had been working on. So during this time, the IOJS project moved forward and cuts version 1, 2, and 3 based on semantic versioning. They had an extremely aggressive release process where basically any time that something was agreed on that it should be landed, it just landed. And when they cut a release, they would just cut a release with the appropriate Semver to signal the release line. This is really great as a way to move a project forward quickly, and there was a lot of ground to catch up on the Node project. But this isn't the best way to do something when you have a project that's being run in production by companies such as NASA and PayPal and Netflix. They need something that's a little bit more reliable, and you can't be expecting your teams to do a Semver major bump every other week and have to fix broken stuff. So Node was put in a foundation, and the projects IOJS and Node were merged as version 4.0 in September of 2015. This is around the same time that I started working on the project. So what we have up here is our release schedule for Node.js. So what you can see up here is Node 0.10, which ended maintenance in October 2016. We could see that 0.12 had a current release, and in October of 2015, it moved into active LTS. And then it was in maintenance until December, at which point, December 31st of this year, we're going to be deprecating Node v 0.12. You'll see we have master here, and we'll talk a little bit more about that and how we manage the different versions. And we have Node v4. Node v4 is the first LTS release of Node. It is currently in an active LTS release process. We'll talk a little bit more about that in a bit. And in April of 2017, that'll move to maintenance. Node v5 was a current release from October 2015 until a little bit after April 2016. So the way that it works right now is we have our current release line. Every 6 months, we do a Semver major bump. And every even release is a release that's going to go into LTS. And every odd release is a release that will be deprecated after the release process. So you can see lower down how we have the same release process for v6, and we have v7, which is the current release, which will be end of life, in October when we bump to v8. So what you'll notice on here is that we have an active LTS and a maintenance LTS. So long-term support lasts for 30 months after the branch has moved out of the current release stream. You have 18 months of active backporting and 12 months of maintenance backporting. So let's dig a little bit more into that. So current, which right now is v7, gets every commit that lands onto master that is in Semver major. So every week or every other week, depending on how many commits are sitting on master, we'll cut a new version of the current release line. That will get a bump to either Semver minor or Semver patch, depending on the commits that are sitting on master. Everything gets in there. These can be updates that may actually have the potential of a regression. But the purpose of this is that by it living on the current release line and going out into production for individuals, we can catch regressions that we're not catching in our review or testing process quickly and before it ends up reaching an LTS. So active LTS is the process of backporting commits that have landed into the current release line onto our active release line. So right now, v4 and v6 are both active LTS. And so we go through and we audit every commit that's landed on master that have moved into current that's been in a release for at least 2 weeks. The idea here is that these can be updates to tests, updates to documentation, and bug fixes. We generally do not backport Semver major commits, Semver minor commits to LTS, but if something makes sense and has a very, very low probability of causing breakages, we have a working group that will vote on it, and sometimes we'll backport Semver minor stuff. An example of that would be we're in the process of releasing some new symbols for OpenSSL to Windows. So there's a lot of hacks that exist in the ecosystem right now to be able to access some OpenSSL symbols when writing native modules on Windows. And by backporting this, we're able to actually get this fixed in production. We have companies such as PayPal who have come to us and told us that they're floating these commits already in production on the LTS release lines. So we know that it's stable. We know that there's a very low chance of breaking things. So it makes sense to backport it. So we also have maintenance LTS. That's the last 12 months of the 30-month cycle. Maintenance LTS is not going to have the same active backporting. We're not going back and getting as many things as possible landed. What we're doing is we're making sure that if there's major security vulnerabilities or major bugs that are found, that we're patching them and releasing security updates. So this happens whenever there's a CVE for something like OpenSSL, which there's been a couple releases on v12 and v10 in the last 6 months for those. This could be a bug that's found. We've had security releases for our own modules for HTTP. We've had security releases for a number of other dependents that we ship. This is really important. We want to make sure that if you go and put something into production on Node, if you went and put something in production on Node v4 when it went LTS a year ago, you're going to have 3 years of support where you don't have to worry about things breaking or about vulnerabilities while you have your code in there. And we believe that that's enough time to give you an upgrade path for your things that you have sitting in production. So, what about master? We've talked about master a little bit, but I didn't talk too much about how we land things. Master is a special case. Any commit that gets approved lands directly into master. We don't have a dev branch. We don't have any special branch for master. We have master and then our release lines that branch off of that. Any Semver major commit, any Semver patch commit, any Semver minor commit, they all just go right into master. And then we cherry pick off of master to our release lines when we're ready to do releases. What this means is if you're ever running off the nightly version of Node that's built off the head, which would right now be a nightly of V8, you have the opportunity or potential of getting major changes that are sitting there. We tend to not land the Semver majors right away all the time. We give it a lot of time. But we also cut off Semver majors landing onto master about a month before we're about to cut a release so that we have the proper time to run an RC and beta and test that things aren't going to break things for people. So how do we manage all of this? Magic, mostly. And particularly we do it with Git magic. And what I really love about Git magic is that Git magic is magic with trees, and that basically makes us elves, which I'm really into. But so we maintain release branches, and this is what's important. We have a 0.12x branch, a 4x branch, a 6x branch, and a 7x branch. These are our release branch lines. We also have staging branches, 12x staging, 4x staging, 6x staging, and 7x staging. Each of these staging branches are where we will cherry pick commits off of master in between releases. So most changes, as I said, have to live in a release for at least 2 weeks before they'll be backported to the LTS staging. But as soon as something lands on master, it can land on 7x staging. Now, the only time where this isn't entirely true is for documentation updates or sometimes for tooling updates. We won't actually wait for things to go out because we need to, like, for a tap reporter update, for example, we need our entire CI release working on all of our different branches. So it's not a fast and hard rule, but for anything that has any potential of breaking things, it needs to be in production before we'll land it on LTS. So let's do a little bit of a demo. And I'm going to be having a screen up here, so if you can't read it, just all of you together just scream enhance, and I'll zoom in a little bit so you can see. But see, here's the Node.js repo. And I'm going to show you a little bit of how our release process works. So we can go here to pull requests, and I'm just going to go and grab a random pull request that I definitely haven't audited or thought that I'm going to use as an example here. This is by my friend Francis. It's a new commit that allows test.py to use the full path of a test. So this is actually really useful for us. We have a test runner, and the test runner is written in Python. And if you go to run that test runner, you can run individual tests. Unfortunately, the test runner was designed that you can't actually pass the full test. So if we take a look here, if we had the word test in front and the .js at the end, the test runner actually wouldn't recognize that path. What it would recognize is without the test directory and without the JS at the end. And that's not really useful if you're working on your own machine and want to run your own tests. So Francis went through, and basically all it does is normalize the path in case you have test in front and JS at the end. And this allows us to now run individual tests. So what we can do here is we can go and grab this commit, and we could copy the link. This is a really cool thing. We'll go and look at when we open it here. We could see the commit. So GitHub actually has this amazing feature where you can add .patch to the end of a commit. They broke it, actually, so you need to, I have a little regex that fixes that. But now we get this git mail message. Come and grab me later if you want to learn more about what a mail message is, but it's the old way in which the Git project used to pass around commits. And you can float a mail message directly onto a tree without having any unexpected changes happening to that tree. So what's really great about this is we can take those mail messages, pass them to git.am, and it's going to patch it directly onto the head of the tree. So we can take this link, we can go here on master, and we can patch it, and we've applied it to the head. So now we can go and look at the commit, and we can see that we have this commit here in a commit message, but it's missing the metadata that we use in the project. So what I can do is I can go back here to the original pull request, and we have this little utility that we use. I'm going to just refresh this really quickly. So the utility is deciding not to work in that version of Chrome. So as we've seen with live coding today being fun, let's try it here for a second. We press this. It's going to generate the metadata that we need for the commit. We're going to go back in here. We're going to paste the metadata into the commit. We're going to save that. We're going to close it. We've now made the commit. And then we're going to push to master. So we've just updated Node. And so what I'm going to do is I'm going to go and grab that commit. I'm going to go back to the thing here. I'm going to say, where it landed, and I'm going to close it. So we've actually landed a pull request onto Node's master branch. So because this is a commit that doesn't affect anything that's problematic, we can actually go ahead and start backporting it onto our various release lines. So we can look here at the head. We can grab this, and we can check out v7.x staging. OK, and now we can cherry pick it. So now we can see it sitting on the staging branch for the next release. And we can push that. And as long as no one else has put anything on the staging branch, we should be good, which we are. So now we've updated it and put it into staging. But what we can also do is take it a step further. We can look here at v6.8. We can update the tree so we can get the commits that are sitting in master. And just while we're doing that, I'm going to update v4 as well. And we can grab this commit, grab that link address. We could patch it on v6. We could patch it on v4. And we can push upstream to both the v6 staging and the v4 staging. So now we've gone ahead and we've landed this update into all of our release lines. So I can go and mark it so that we know that it's ready to go. So we've gone ahead and taken this commit that fixes our tooling. We've updated all of our release lines, and it's ready to go in all of our next releases for Node. So this is kind of an example of what the release process looks like. So if any of you have more questions about how we manage that release, come and grab me. But this is the process of landing code onto Node and updating our different release processes. So when we're ready for a release, we'll go and we'll branch off of the 4.x, 6.x, or 7x branches, and then we'll cherry pick our commits that are sitting on staging ready to go into the release. How do we know which commits we're going to cherry pick? We primarily know through GitHub labels. So every commit that's c.c.r.m.a major has a label. Every commit that's c.c.r.m.a minor has a label. We also have LTS watch labels, and we have don't land labels. So if I go back to the repo here for a second, and we go to our pull requests here, we could go here and we can say, hey, what's everything that we have on v4. LTS watch for v4.x. And we're going to see all the stuff that's ready to land there, and we can do LTS watch for 6.x as well. And now we have a list of all the commits that are ready to land on both that have closed and already landed on master. We have a big list here. So we can go back here and we can see that there's another commit that I was looking at, which is this right here, which changes a deprecated method that isn't supposed to exist but still does. And we can see that this was landed by Franzi, who's sitting in the audience right now, and she landed it in AB 1941-2. And so I asked her if it should be backported, and she said that if it lands cleanly, we can. So we can go ahead and we can copy this commit that's ready to land, and we can run our patch command. But it didn't work, which is unfortunate but expected. So we can actually just say please. And now we're going to use a three-way merge strategy instead of the git merge strategy. And we push it upstream. And we can see there's the commit. And I think that it's already landed. So now we can go back to v4, and we can try to patch it. And we're going to see, oh, wait, it didn't work. So we can see what's going on. We can see there's actually a diff in Node.cc. And we can see that there's actually some stuff that exists on this tree that doesn't exist in v4. And generally, when we start touching C++ and changes that I'm not familiar with, I get kind of nervous. So what I'm going to do is I'm actually just going to abort this. I'm going to go back to this. I'm going to switch the tag for LTS watch v6 and let them know that we've landed it. But what I'm also going to do is I'm going to add a label to say don't land it on v4 because it didn't land cleanly. We're going to see those labels update. We're going to go down here, and I'm going to just message Franzi and just say, landed cleanly on v6, but not v4. Please feel free to manually backport. So now we've gone, it's landed on 6, it's ready to go in a 6 release. It didn't land on 4, so we put a label so that we know that it's not going to land on the 4 in the future, but we've messaged someone to give them the opportunity to land it later if we'd like. So This is how we go through. And we have tools that we can use that can automate going through all of these different labels. So if we're on v6 right here, we can use this tool called branch diff, and we can say, hey, what's the difference between v6.8 staging and v6.x? And it's nothing, which is fun. But we could then go and say, well, what's the difference between v6 and master? And it's going to go through, and it's going to grab every single commit. It's going to compare them based on labels. And what's really cool about this tool is instead of doing it based on the tree, which is what a git diff usually does, it does it based on our metadata, and it does it based on the titles of the commit. So what it can do is we actually care about atomic change. Atomic change is not the same thing as the changes in which we have in a git tree. So a diff between two trees that have different changes are going to be a diff, but what we care about are the actual commits. So now what we can see here are all the commits that are on master that are not on v6. And there's a whole bunch, and a lot of them are semver major. So what we're able to do is actually make a whole bunch of different labels, and you can see here, if I go to github.com to my gists, I maintain a gist of various audits that I'm doing, and we can see the audit of v6. This is the command that includes excluding labels, and these are all the commits that still need to be labeled. They have not yet been labeled. They live on master, not yet on v6. And I go through periodically, once every 2 weeks or so, and audit these. The last time I actually did a live stream of it and explained commits, what was going through, what was happening. If you follow me on Twitter at @thealphanerd, I'll tweet on there whenever I'm going to be doing these live sessions. And if enough of you from Singapore are interested, because I have a really weird sleep schedule, I'd totally be up for doing it at a time that's reasonable for you. But so now that we have these labels, we're able to use tools like I was talking about. Release tools, including branch diff, to find the difference. Release tools such as changelog maker, which can use those diffs between the branches and generate our changelog for us. We also have various scripts that we use during the release. And all of those allow us to do our release process and automate it. So we got a little bit of time left. So we're going to talk a little bit about what is a breaking change. I love this one. I really hope no one got hurt, but it's just, I don't know, it's pretty glorious. I know I just said I don't have a lot of time, but I'm just going to watch it anyways. So, as we talked about before, what's a semver major change? What's a breaking change? It's a change in behavior. Generally, a change in behavior is obvious, but sometimes we can be really surprised. And we're going to talk a little bit about how we figure out if we have breaking changes, and then look at an example of one that's unexpected. So, how do we avoid breaking changes? There's obvious ways. Continuous integration and a large testing suite. But we also do something called smoke testing. So one of the utilities that I've worked on is called Canary in the Gold Mine. What it will do is it will actually go and grab the tarball from GitHub of a module. It will untar it. It will npm install it. And then it will run npm test. It will then take the results of that test and give us the results. So you can npm install this, npm install c.c.r.m.a, and start running test suites on your laptop if you want. But what's interesting is it also comes with a lookup table of the top 70 modules in the ecosystem that we've derived for a number of different reasons. We then run that in CI, and we can run the test suite, automate the test suite of 70 of the top modules in npm, and then get those results to see if something's broken. And we can run that test on any arbitrary commit of Node. We are now at the point where we will not land a semver major change or do a release if anything is broken in Canary in the Gold Mine. So what this means is that anytime someone sends a commit that's questionable, we can run Canary in the Gold Mine and we can tell whether or not we've actually broken something in the ecosystem. So once upon a time, Canary in the Gold Mine found some failures. There was a failure in Jade and a failure in body parser. So it turned out that Jade just moved their orgs and didn't update their package JSON. So this was an example of where we didn't actually break anything, but the modules themselves broke something. And this has been an awesome side effect of Canary in the Gold Mine that wasn't expected, was that when we actually we're able to test that these orgs have broken things, we can actually give a heads up to people, hey, your module is broken, and they love it. 2 days ago, we actually found that Ember CLI pushed some stuff that was unexpected that broke Node in a weird way just on v4, and we were able to let them know within 2 days of their release, and they were able to get an update out in about 30 minutes because they were so adamant that they would be tested in Canary in the Gold Mine that they worked with us super quickly. So the next one that broke was body parser. How many people here know what body parser is? Can I see a number of hands? How many people here know what Express is? Cool. So Express is a tool that's used for running all sorts of servers. It's used inside of PayPal's Kraken, so an idea of how much it's used. So there was an optimization done to query string.parse that took a length. And this is the change that came in. And we can see just like right here, essentially, originally, we just checked if the max keys was larger than the length, and then we just cut it. And instead, we realized that you can, to string.split, you could pass a max length. And in doing so, we were able to have an optimization and not create lots of garbage. So one thing we didn't account for was infinity. Because based on the spec, the number that you give for max length is actually an integer. And when infinity gets inferred to be an integer, it infers to 0. So Body Parser actually had a test for this, and we found out that basically what would originally have passed 1 with this code started passing 0. So this was a code that was a small optimization. It was something that easily would have been backported. We would have had no idea that this could have broken code in production. But I mean, this is an extremely hot code. This could have broken the world, but Canary in the Gold Mine found it. Smoke testing saved the day. So with the change had landed on master, but not going out in a release yet, so we were able to land a fix before it even hit userland. So let's quickly wrap up. Which version should you use? 4x has had a while on LTS to stabilize. 6x has been on LTS for about a month, and it's getting ready for its 3rd LTS release. And v7 is always getting the latest and greatest things. So why use v4? Hardened by an ongoing release process. You already have an app in production that's working. You probably should just stick to v4 right now. Why use v6? It's going to have the longest support cycle of all the LTS releases that are out right now, and it's the closer to master of all the LTS releases. It also comes with v8 5.1, which has a much larger coverage of ES6 than 4.8, which was in Node v4. And it has the inspector API. I don't know if you've used that yet. Some people have talked about it earlier this conference. It's awesome. Do you have to use LTS? No, you can do whatever you want. I'm not the boss of you. But if you want to use 6x, what you're going to get is v8 5.4. You're going to get a little bit of ES 2016. You can use 2 stars for doing exponents, which is super cool. And you're going to have the latest and greatest stuff. But if you use it in production, I'm going to be really scared. So, be prepared for breakages if you're an early adopter. And that's just kind of the message that I'll leave you with there. So, thank you all so much. This is a dog surfing.